Okay, let's look at some components of vectors. If I have a vector, let's say I've got 40 meters per second and it's going at 35 degrees above the horizon, okay? If I'm not going totally horizontal or totally vertical, I can really break this vector down into two vectors, one along the x-axis and one along the y-axis. So this is often useful in physics. So let's go ahead and do that. I can say this vector is going to equal my x vector, which I'm just going to call vx, velocity in the x direction, and a y vector, which I'm going to call vy, the velocity in the y direction. Okay? So if I've got this going 40 meters per second in 35 degrees above the x-axis, what is my x and y velocities? How can I convert that? And to do that, I've got to do a little trigonometry, okay? Because really, I can calculate this velocity if I have this velocity and this angle, and I have a right triangle, okay, by saying that the velocity x is equal to the initial velocity times the cosine of theta. In this case, theta is 35 degrees, okay? If we go ahead and plug in the cosine of 35 degrees is 0.8191 and multiply that by our 40.0 meters per second, we get 32.76 meters per second, okay? Now is that okay? Is that perfect? Well, if we want to go with significant figures, we have three significant figures in our initial value right there. So let's go ahead and convert that to v of x equals 32.8 meters per second, okay? So my vx equals 32.8 meters per second. Okay, now let's look at the y vector, okay? In this case, my y vector, when I compare it to v1, okay, I can calculate that by saying my vector y equals my initial vector times the sine of theta. Remember, sine is a relationship between this and this side and this side, okay? So in this case, the sine of 35 degrees is 0.53735, and I multiply that by 40 meters per second. I get 22.94 meters per second, okay? And again, knowing that I have three significant figures in my initial value, let's calculate Vy into 22.9 meters per second. And this equals 22.9 meters per second. Okay, so what we've done here is we've taken one vector and broken it down into its x and y components. In this case, a velocity in an angle equals a velocity in x and a velocity in y.